Not even 10 American mechanics could fix this Ram. The words were delivered with the heavy sigh of defeat by David Miller, 54 years old, owner of a construction company in Billings, Montana. He was gesturing at a truck that had become the most expensive and frustrating paperweight in his fleet, a 2018 Ram 3500 with a 6.7L Cummins diesel engine, 180,000 miles on the odometer, and a problem that had stumped every single mechanic who had laid hands on it for the past 7 weeks. The truck sat silently in the service bay of Miller's own maintenance shop, a massive 4-bay facility designed to service his company's heavy equipment, and stubbornly refused to do the one thing it was built for: start. The engine would crank. The starter motor engaged with perfect force, turning the high-compression diesel over with that characteristic rhythmic resistance that told you everything mechanical was sound. But it wouldn't fire. It wouldn't catch. It wouldn't even sputter. Just the sound of endless cranking followed by a deafening silence and the faint unburnt smell of diesel fuel hanging in the air like a taunt. But before we dive into how one mechanic from Idaho figured out what 10 others had missed, I want to ask you something. Where are you watching this story from? Are you in the United States, Canada, somewhere else in the world? Drop a comment below and let me know your city or country. And tell me this: have you ever been the absolute last hope for solving a problem after multiple experts had already failed and given up? Let's build a community of people who refuse to quit, even when something seems impossible. This Ram 3500 was the workhorse of Miller's fleet. It was used for hauling heavy equipment between job sites, pulling trailers loaded with raw materials, and navigating the rough, muddy construction sites of rural Montana, where 4-wheel drive and massive torque were non-negotiable. For 4 years and 180,000 hard-working miles, it had been perfectly reliable, maintained meticulously by Miller's in-house team according to factory service intervals. Then, 7 weeks ago, a driver had parked it at a job site in the morning, worked for 3 hours, returned to the truck, and it wouldn't start. Miller's head mechanic, a 30-year veteran named Frank, had spent 2 full days on it, running diagnostics, checking the entire fuel system, and verifying electrical connections. He found nothing. They'd towed it to the local Ram dealership in Billings. The dealership, confident in their factory training, kept it for a week, diagnosed it as a failed high-pressure fuel pump and a set of bad injectors, and replaced everything at a cost of $7,500. Miller paid the bill, relieved to have his truck back. It ran perfectly for 2 days, then died in a parking lot with the exact same symptom. Miller had it towed back to the dealership, furious. They kept it for another week, this time claiming it must be an intermittent electrical issue, and spent 40 hours of labor tracing wires without finding any conclusive faults. Frustrated and losing money every day the truck was down, Miller took it to an independent diesel specialist shop in Bozeman, a shop with a regional reputation for solving complex problems. That shop had the truck for 3 weeks. They chased electrical gremlins, replaced the camshaft position sensor, the crankshaft position sensor, the throttle position sensor, and even tried a replacement engine control module, ECM, from a donor truck, hoping it was a computer issue. Nothing worked. The bill from the specialist was another $6,200 in diagnostic time and parts that didn't solve the problem. By now, a total of 10 mechanics from 4 different shops, including Ram's own factory-trained technicians, had all failed. The diagnostic and repair bills exceeded $14,000, and the truck, a vital piece of his business, was still dead, sitting uselessly in Miller's own shop, a monument to their collective failure. Miller was out of options, out of patience, and almost completely out of hope. He was ready to sell it for scrap. The person who represented that last, desperate sliver of hope stood calmly next to the truck, wiping her hands on a shop rag. Her work boots were covered in the dust of a long drive, her expression one of focused concentration as she listened to David's frustrated summary of the past 7 weeks. Her name was Jessica Evans, 36 years old, the owner and lead diagnostic technician at Evans Performance Diesel, a small, unassuming 2-bay shop in a rural Idaho town. Her specialty was exactly this: complex Cummins, Power Stroke, and Duramax diesel problems that other shops, even dealerships and well-regarded specialists, couldn't solve. She didn't advertise. She didn't have a flashy website or a big social media presence. She just fixed trucks. Really fixed them. with a deep diagnostic skill that went beyond just reading codes or following standard service manual flowcharts. Miller had been skeptical when a friend on a trucking forum recommended the woman in Idaho who fixes impossible Cummins issues, but he was desperate enough to try anything. He'd called her, described the problem, and she'd asked a few pointed questions that showed a level of understanding nobody else had. She'd agreed to drive the 6 hours from Idaho that morning to take a look. No promises, no guarantees, just a professional curiosity and a hunch. Miller had agreed, figuring another few $100s for a diagnostic visit was a drop in the bucket compared to the $14,000 he'd already wasted. David finished his explanation with a heavy sigh, the sound of a practical man defeated by a machine he was supposed to master. So that's the whole story. 10 mechanics, 2 months, 14 grand down the drain, and I've got a very expensive lawn ornament. The dealership says it needs a new engine computer, which is on national back order for 6 months. The specialist in Bozeman thinks it's a wiring harness issue but can't find a short. My guys think the truck is cursed. Jessica nodded slowly, her eyes still on the truck, not on David. Cursed is just a word for a problem we haven't understood yet. Mind if I take a look? David gestured at the truck, his hands open in a gesture of surrender. Be my guest, but if you can't figure it out, I'm selling it for scrap. I'm done with this thing. Jessica walked to the truck, opened the driver's door, and turned the key to the accessory position. The gauges swept through their self-test. The dashboard lights came on and then went off as expected. Everything looked perfectly normal. She turned the key to start. The engine cranked, strong, consistent, the high compression rhythm of a healthy diesel engine. But it wouldn't fire, just that sound of endless, fruitless cranking. She turned it off and sat in the driver's seat for a moment, listening to the silence, her mind already building a diagnostic strategy based on the symptoms and the history of failed repairs. Then she popped the hood and started her process, not by touching anything, but by observing. The engine bay was clean despite the mileage, a testament to Miller's good maintenance program. The recent work was obvious. The new high-pressure fuel pump was shiny and clean, the new injectors were spotless, the new fuel rail gleamed under the shop lights. Everything looked perfect. Too perfect. Jessica had learned over 12 years of specializing in impossible diesel problems that when everything looks right but nothing works, the problem is either invisible to the naked eye or so simple that it's been overlooked by mechanics trained to look for complex failures. She started with the basics, re-verifying the work of the previous 10 mechanics, not because she didn't trust them, but because you cannot build a reliable diagnosis on unverified assumptions. First, fuel pressure. The Cummins 6.7L engine has 2 fuel systems, operating in sequence: a low-pressure lift pump that moves diesel from the tank to the engine, and a high-pressure pump, the CP3 pump, that pressurizes it up to an incredible 26,000 psi for injection. She connected her mechanical pressure gauge to the low-pressure test port, located between the fuel filter and the high-pressure pump. She had one of Miller's techs crank the engine. The gauge showed a steady 15 psi. Perfect. The lift pump was working correctly. Next, she connected her high-pressure gauge to the fuel rail test port. She cranked the engine again. The gauge needle climbed smoothly and quickly, 2,000 psi, 3,000, 4,000, stabilizing at 5,000 psi during cranking, which is the target pressure required for starting. So fuel pressure, both low and high, was definitely good. This immediately told her that the dealership had likely replaced a perfectly good high-pressure pump and injectors at a cost of $7,500. Next, she checked the electrical signals. She connected a Noid light, a special test light designed to check for injector signals, to the electrical connector for cylinder 1's injector. She had the tech crank the engine. The light flashed rapidly and brightly. Good signal. She moved the light to cylinder 4. Good signal. Cylinder 6, good signal. The engine computer was clearly commanding the injectors to fire, so, to recap, fuel was present at the correct high pressure and the injectors were receiving the correct firing commands. Why wasn't it starting? At this point, most mechanics would start suspecting deeper, more complex issues. Maybe a catastrophic compression problem, unlikely on a well-maintained Cummins with only 180,000 miles. Maybe a timing problem, Also unlikely, as the gear-driven timing on these engines is famously robust and doesn't slip. Or maybe, as the dealership had ultimately suggested, the engine computer itself was faulty. But Jessica thought differently. She knew that modern diesel engines are completely reliant on a complex network of sensors. The engine computer won't allow injection to occur if it thinks something is catastrophically wrong, even if nothing actually is. The problem wasn't mechanical, it was likely logical. So she started looking at the sensor data. She connected her high-end diagnostic scanner, a $12,000 Autel MaxiSys Ultra, with more processing power than a standard laptop, to the truck's OBD2 port. She started monitoring live data streams from the engine's key sensors while cranking the engine. Camshaft position sensor, reading a steady RPM signal, looked clean. Crankshaft position sensor, also reading RPM signal clean and perfectly in sync with the cam sensor. This confirmed that the engine's timing was correct. Coolant temperature sensor, oil pressure sensor, intake air temperature sensor, all were reading plausible values for a cold engine sitting in a shop. Then she looked at the fuel rail pressure sensor reading. The computer was reporting 5,000 psi during cranking, exactly what her mechanical gauge had shown. So the sensor was accurate. This was getting strange. All the critical inputs required for starting were present and correct. Fuel pressure, cam crank synchronization, and injector command signals. The engine should be running. This was the point where the previous 10 mechanics had hit a wall and started guessing. But this is where Jessica's experience with impossible problems set her apart. When all the normal diagnostic paths lead to a dead end, you have to start thinking about what isn't normal. What could prevent injection even if all the primary conditions are met? She pulled up the complete wiring diagram for the Ram's engine management system on her tablet and started tracing the power and ground circuits for the fuel injectors. The injectors on a common rail diesel don't just get a simple on-off signal like in a gasoline engine. They receive complex, high-voltage, multi-stage pulses from a dedicated driver module inside the engine computer. That module needs perfectly clean power and an absolutely perfect ground reference to function correctly. She checked the main power feeds to the ECM. All good, solid voltage. She checked the main grounds for the ECM. All clean, tight, with resistance measuring less than 0.1 ohms. The previous mechanics had clearly checked these as well. Then Jessica noticed something on the wiring diagram that was incredibly easy to overlook. It was a small, seemingly insignificant circuit, labeled injector return line. On a Cummins common rail engine, each injector has a tiny internal passage that bleeds off a minuscule amount of fuel. This fuel is used for internal lubrication and cooling of the injector's moving parts. This fuel is then sent back to the tank through a low-pressure return line. The 6 individual return lines from each injector all feed into a common return manifold. That manifold has a banjo bolt connecting it to the main return line that goes back to the fuel tank. And mounted directly on that banjo bolt was a sensor, the fuel injector return flow sensor. This sensor's job is to act as a safety monitor. It detects if one or more injectors is leaking internally. A failing or stuck open injector will bleed off too much fuel into the return line. The sensor measures this flow rate. If the flow exceeds a certain pre-programmed threshold, the engine computer assumes there's a catastrophic injector leak happening. To prevent a situation where a failed injector could wash out a cylinder with unburned fuel, severely dilute the engine oil, or even cause a dangerous runaway engine condition, the computer's safety protocol kicks in. It will shut down the engine completely, or in this case, prevent it from starting. It's a critical safety interlock that most mechanics don't even know exists. Jessica had a hunch, a strong one. She located the banjo bolt on the side of the engine block where the 6 injector return lines converged. It was tucked away, hard to see, and partially obscured by other components. She carefully disconnected the electrical connector from the sensor mounted on that banjo bolt. Then she walked back to the driver's seat, turned the key, and told one of Miller's techs to stand by with a fire extinguisher. This was her standard procedure when bypassing any factory safety systems. She turned the key to the start position. The engine cranked once, twice, and then it fired. It caught, stumbled for a second as the system purged air, then roared to life, settling into the smooth, confident, powerful idle of a healthy Cummins diesel. The sound of that engine running for the first time in 7 weeks echoed through the massive shop, making every mechanic stop what they were doing and stare in disbelief. David Miller's jaw literally dropped. The mechanics who'd been beaten by this truck for weeks just looked on in stunned silence. Jessica let it run for 10 seconds, confirming stable operation, then shut it off. The total time from when she had first started her diagnosis to starting the engine, 47 minutes. She climbed out of the truck, walked over to David, and held up the small electrical connector she had unplugged from the sensor. Found your problem. This is the connector for the injector return flow sensor. When I disconnect it, the engine starts. That means the sensor is detecting high return flow, telling the computer there's a major injector leak and preventing the engine from starting as a safety measure. But you just had the injectors replaced, so we know they're not leaking, which means the sensor itself has failed. It's sending a false signal, tricking the computer into thinking there's a catastrophic failure when there isn't. David stared at the small connector in her hand, then at the engine, which was now silent again, but proven to be functional, then back at Jessica. His expression was a mixture of shock, relief, and dawning comprehension. A sensor, a single sensor that none of us even thought to check. Jessica nodded. It's an obscure sensor. It's not part of the standard no-start diagnostic flowchart in the service manual. Most techs, even factory-trained ones, don't know it exists or what it does. You only start looking for it when you've eliminated everything else and have to start thinking about what safety interlocks could be preventing injection. The dealership replaced the injectors and pump because high return flow is a symptom of failed injectors. They were treating the symptom, but they didn't realize the sensor that reports the symptom was the actual root cause. David was speechless for a moment. 10 mechanics, 2 months, $14,000 in wasted parts and labor, all defeated by a single $100 sensor that was sending a false signal. He looked at Jessica with a new level of respect, bordering on awe. How did you know to check that? How did you even know that sensor existed? Because I've seen this exact failure before. Twice, actually, on logging trucks up in the Idaho mountains where conditions are tough. It's a rare failure mode, but when it happens, it creates symptoms that look exactly like a major fuel system failure. You can spend thousands replacing pumps and injectors and never fix it, because the problem isn't mechanical. It's a logic error caused by bad sensor data. To prove the point, Jessica plugged the connector back in, tried to start the engine again. Nothing. Just cranking. She unplugged it again. It started immediately. The diagnosis was definitively confirmed. She ordered a new fuel injector return flow sensor from the local parts store. It was a standard Bosch part, in stock, and it cost $112. It arrived an hour later. She installed it, a 10-minute job requiring a single wrench. She plugged in the connector. She started the truck. It fired up perfectly. She shut it off, started it again 5 times in a row. Perfect start every time. The fix was complete. David walked over to his office desk and pulled out his company checkbook. What do I owe you? Jessica consulted the notes on her phone. $500 for the diagnostic visit, plus 3 hours of labor at my shop rate of $125 an hour, plus $112 for the part. The total comes to $987. David wrote a check for $5,000 and handed it to her. No. I'm paying you for the 2 months of headaches you just solved in 3 hours. I'm paying you for saving me from buying a new engine, computer that wouldn't have fixed it, or scrapping a $40,000 truck that was perfectly fine. This is the best money I've spent all year. Thank you. Jessica saw the genuine gratitude in his eyes. She'd seen it before from customers who'd been told their equipment was unfixable. She accepted the check. You're welcome. And for what it's worth, tell your mechanics to remember this sensor. It'll save you money next time. The story spread through Miller's construction company like wildfire. The Azure mechanics who'd been beaten by the truck for weeks crowded around Jessica, asking questions, wanting to understand her diagnostic process, how she'd known to look for that obscure sensor. She spent an hour walking them through her methodology, how she verifies the basics first, then uses scan tool data to build a mental model of what the engine is doing, then starts looking for discrepancies between what the computer thinks is happening and what's actually happening. She explained that modern engines aren't just mechanical objects, they're complex computer networks on wheels. And you have to be able to diagnose the software and sensor logic just as much as the hardware. The mechanics listened, humbled, but grateful for the lesson. David Miller offered Jessica a lucrative contract to be the on-call diagnostic consultant for his entire fleet of heavy equipment. She accepted. The contract brought in steady income and a stream of interesting new problems to solve. The Ram 3500 went back into service immediately and ran flawlessly for another 200,000 miles, becoming a rolling reminder in Miller's fleet of the time a woman from Idaho came and fixed what 10 Montana mechanics couldn't in under an hour. Word of the miraculous repair eventually got back to the Ram dealership and the independent specialist shop that had misdiagnosed the problem. Both shop owners called Jessica to ask about the diagnosis. She explained it calmly, professionally, without blame or ego. She just shared the information, explaining the failure mode of the sensor and how it tricked the ECM. Both shops implemented new diagnostic procedures based on her findings. The dealership even sent 2 of their lead diesel technicians to shadow Jessica at her shop for a week to learn her diagnostic methods. They came back with a new understanding of how to approach complex, data-driven problems. The regional Ram service representative for the entire Northwest region called to thank her for identifying a rare failure mode that their factory training hadn't covered. Her diagnosis was written up and distributed in a technical service bulletin to Ram dealerships nationwide. Thousands of technicians across the country learned about the injector return flow sensor and its potential to cause no-start conditions that mimic catastrophic fuel system failure. All because Jessica had questioned an assumption. Jessica's business in rural Idaho grew exponentially. Fleet owners from Montana, Wyoming, and Utah started sending her their most difficult problems, bypassing closer shops because they knew she'd find the root cause. She hired 2 additional technicians and a service writer to handle the increased workload. She expanded her shop from 2 bays to 6. She invested in more advanced diagnostic equipment, picoscopes, pressure transducers, specialized software. But she never changed her fundamental approach. Be thorough, question everything, trust data, but verify it with mechanical tests, and never ever assume a problem is impossible just because it's difficult. She started teaching weekend diagnostic classes for other mechanics, not just teaching them what to test, but how to think about problems, how to build diagnostic strategies, how to find the root cause instead of just treating symptoms by replacing parts. The classes sold out months in advance. Mechanics who attended reported that her 2-day class taught them more about real-world diagnostics than their entire formal schooling. The story became legendary in the diesel mechanic community. Not because of social media fame or viral videos. Jessica didn't care about any of that. It became legendary because mechanics talk to mechanics, and when someone solves a problem that stumped a dealership and a specialty shop in under an hour, word gets around. The Idaho Cummins Whisperer, they started calling her. The woman who could fix what nobody else could. She never sought the reputation, but her relentless skill earned it. And every time a mechanic somewhere in the country faced a Cummins no-start that made no sense, someone in a forum or a Facebook group would inevitably say, "Have you checked the injector return flow sensor? Remember that story about the Ram in Montana?" That was her legacy. Not fame, not money, but shared knowledge that made the entire industry better. So one final time, where are you watching from? And what's your story of solving a problem that stumped the experts? When did you find a simple solution to a complex issue? Because you thought differently? Because you looked where nobody else thought to look? Drop it in the comments below. Because Jessica Evans proved that expertise isn't about how many people try to solve a problem. It's about how one person thinks about the problem. That the most expensive and frustrating issues sometimes have the simplest, cheapest solutions. And that a curse is just a diagnosis we haven't made yet. Let's build a community that solves the unsolvable together.